Hello student, welcome into our second lesson. And in our first lesson, we learned about the moments of a force. We also learned about the factors affecting the moment of a force. And also we looked at the activities where the force produces the turning effect. In this lesson, we are going to learn the following. One, we are going to learn about the principle of moment, whereby we have several moments, whereby we have in case of parallel forces, and we also have in case of anti-parallel forces, or what we call the couples. We are also going to do some numerical examples to illustrate the principles of moment. Let us begin our discussion. And for us to understand the principle of moment, we consider the following meter rule, and of course it is balanced, or it is at equilibrium, and we have several weights which we are going to call W1, W2, W3, and W4 as shown below. And then they are at different distances from the pivot. And the forces W1 and W2, these ones, will tend to make the ruler to turn in the anti-clockwise direction about the pivot. Therefore, they produce what we call the anti-clockwise moment. So what we mean here is, if for example we remove this and this, how will this ruler behave as if? Of course, it will behave as if it wants to turn toward this direction, It wants to fall onto this direction. Therefore, that is what we are calling anti-clockwise moment. And also, we have W3 and W4, which will tend to make this ruler, this rule, to turn in the clockwise direction, and therefore they produce what we call the clockwise moment. So if, for example, we tend to remove this one and this, it means that this ruler will turn in this direction, this one here, to add this from here down one like this. So it means that that direction is clockwise direction, and therefore the moment produced is called clockwise moment. Then we have the sum of clockwise moment. Of course, in the first lesson, we learned about how to calculate the moment, whereby we said it is a force times the distance from the perpendicular distance from the point of support to the line of action of the force. For example, if we have W3, the perpendicular distance from this line of action here to the point of support is D3. And also we have another force which is causing the clockwise moment, which is W4. And then the perpendicular distance from this line of action, which is this, to the point of support, which is this fulcrum, is D4. Then we have also sum of anti-clockwise moment, which we have this weight here will produce anti-clockwise moment, and its moment will be this W3 multiplied by the perpendicular distance from the line of action to point of support, which is this fulcrum. Of course, it should be D1, and the same implies to W2. At equilibrium, or when this meter rule is balanced, it means that the sum of clockwise moment will be equal to the sum of anti-clockwise moment. Therefore, these are the clockwise moments. So you will equate the two. And this will now form what we call the principle of moment here. The principle of moment. Whereby we say that when the system is at balance, or it is actually balanced, it is at equilibrium this way, the sum of clockwise moments about a point, and a point means this fulcrum here, where that fulcrum is, that is the point we are calling, must be equal to the sum of anti-clockwise moments about the same point, so you don't change the pivot, exactly the same point. Let us go through some examples so that we understand even better the principle of moments. We have a boy of mass 40 kg sits at a point 2 meters from the pivot of a seesaw. Find the weight of a girl who can balance the seesaw by sitting at a distance of 3.0 meters from the pivot. So we are told to take G as 10 newtons per kg. Let us go through the solution. So this is now the seesaw here. Of course, we have this boy. Of course, we are told he is 40 kilograms, 40 kgs. The girl, we don't know the weight. That is our question. And this one, the girl will produce which moment? Of course, the clockwise. At equilibrium or at balance, sum of clockwise moment is equal to the sum of anticlockwise moment. That is from the principle of moment. Therefore, we have the clockwise moment is, we have said the girl will produce the girl will produce the clockwise moment. So you take the weight of that girl, which we will call WG, times the perpendicular distance from here to the point of support. Of course, it is 30 meters, is equal to 40 kilograms times 10 newtons per kilograms. Of course, this one will produce our weight. This one, of course, we say that weight is a force, so it means that this one will be our force times now the distance, which is of course perpendicular from the point of support to where the boy is here. So this distance. Therefore, it means that we have 3WG is equal to, if you multiply the whole of this, you will get 800. And therefore, the weight of the girl will be, if I divide through by 3, the weight of the girl will be 266.67 newtons. Let us proceed to what we call the parallel forces. We need also to know what will be the moment of parallel forces. Let us consider a uniform rod below, balanced by the forces F1, F2, F3, F4, F5, and R. R is now the weight, which is the normal reaction on the pivot. So these are the forces we are having here. We have all these forces here. They try to keep this load in equilibrium at this point. So the forces F1, F2, F3, F4, F5, and R are parallel. What does that mean? It means that it cannot meet at a particular point. So this one is parallel to this, is parallel to this, is parallel to this. So each force is parallel to the other force. Then we have the sum of clockwise moment is equal to the sum of anticlockwise moment. That means the sum of the moment of parallel forces is 0. So that means if I add the forces on the upper side plus the forces on the lower side, I should get 0. Why? This is because they are equal. And if you add this, and of course they are facing different directions, that is why it is 0. Because this one faces the upper side and the other ones face the lower side, and that means the direction is not the same. Then we have the anti-parallel forces, or what we call the couples. Anti-parallel forces refers to equal, parallel, but opposite forces. The total moment of anti-parallel forces is the product of one of the force and the perpendicular distance between these forces. Therefore, you have this is one force and this is another force, and the distance between them is this. So if you want to calculate the moment on this load here, you take one of the force. You can maybe take this one and multiply by this distance between the two. So this one is a little bit different from this one, because here we consider two forces, this one and that. Examples of cases of couples, these ones. We have force applied on a wheel spanner when tightening or loosening a nut. We have force applied when opening a water tap. So you realize that you apply forces which are equal but in opposite direction. Then also we have forces applied on the steering wheel of a car when going around a bend. So you apply also two forces which must be equal in forces, or equal in magnitude, equal in size, but they are facing different direction. Let us also do some example 2, and we have that we have two vertical equal and opposite forces act on a metal rule at the 12 centimeter and 80 centimeter marks respectively. If each of the force has a magnitude of 3.6 newtons, calculate their moment on the metal rule about 28 centimeter mark. The solution. So first of all, we have this diagram here, and of course you can be able to see this force and also this one. So if you want to know the moment, you take maybe you can start with the upward moment, whereby we have this force produces the upward moment. Means you take this force, which is 3.6 newtons, multiply by the distance from here to here. Of course, it is very clear because they are saying about. About means that is where the pivot is. So the distance from here to here is 0.16 here. Then you take 3.6 times 0.16, then you will get this. Then we have moment due to downward force. You take this force, which is bringing about the downward moment. So you take 3.6 newtons times the distance from here to here. Therefore, it means you can take 0.80 minus 0.28, and therefore, what will you get? You will get a 0.52, then you multiply with this force. The answer will be this. And therefore, the total moment will be, you take the first moment, which is this one. Okay, sorry, this one here. You add the downward moment, which is, of course, this one. And the total moment will be this one. Then also we can do another example, which is example 3. Have a metal rule is pivoted at its center. A glass block is hung from one end, and the rule is balanced horizontally by hanging masses of 100 grams and 50 grams at 60 centimeters and 80 centimeters marks respectively. Calculate the mass of the glass block. So this is now what we have here, what we are provided with, and we have a glass block which is hanged on this side. Then calculate the mass of the glass block. So let us proceed. we have taking moment about the pivot. You will have the clockwise moment will be 0.1 meters times 1 Newton plus 0.3 times 0.5, and then the total anti-clockwise moment will be equal to weight of now the glass block multiplied by the distance from where we have the pivot, which is 0.5 meters. And at equilibrium, we say that clockwise moment is equals to anti-clockwise moment. That is according to the principle of moment. Therefore, we have the clockwise moment is whatever we have gotten here, which is this. Then the anti-clockwise moment is this one here. And therefore, if we divide through by 0.5 on both sides, we will get that the weight of the glass block is 0.5 newtons. And from this, mass can be given by weight all over the gravitational constant, which is 10. You take the weight now, you divide by 10 newtons per kg, then you find that the mass of that glass block is 0.05 kgs. How was the lesson? Hopefully you have gotten the best out of our lesson today, and it is always good whenever you don't understand, you replay our video again and again until the point where you will feel that, wow, this is okay. And we always pray for you to have the best lesson and to have the best understanding, because in Colonet Africa we are very concerned about your tomorrow, because we believe your tomorrow starts today. So whatever you do today will determine how your future will be. And therefore in Colonet you are ready. Whenever you need assistance from us, we are always ready for you. And you can also test yourself how far you have understood by going through the following assignments. I have some good questions for you. Try to go through these questions. They are very, very nice. They will test your understanding, and also they will test also your reasoning also, like number 2 here. And the answers, we have generally looked at all these questions, and I'm sure they will be easy for you as you go through the notes. Here we always pray for the best from our side. You do your best and God will do the rest. And until next time, bye bye. Meet you soon.